Hello everyone. Topic selected is Deduplicating training data mitigates privacy risks in language models. These are the contents that will be delivered in the presentation. Firstly, let me explain what is language models. These are the systems trained to predict the next word in a sequence of text. And let me explain what is deduplication means. This is to eliminate duplicate or redundant data information from the dataset. Coming to the introduction, language models are powerful machine learning models that have revolutionized natural language processing tasks. However, the use of language models on large scale training datasets raises significant privacy concerns, as these models have been shown to memorize sensitive information from the training data. In this paper, the authors propose a novel technique for mitigating privacy risks in LMs by deduplicating the training data. The approach involves removing duplicate instances of text from the training set. By doing so, the authors show that it is possible to significantly reduce the amount of sensitive information that is included in the training data. This in turn reduces the risk of privacy violations when the language model is deployed. Coming to the objective. The objective of the paper is to mitigate privacy risks in language models by proposing a method for duplicating training data. The authors aim to reduce the chances of language model memorizing sensitive information from the training data, which can be threat to the privacy of individuals whose data is included in the training set. They propose a simple yet effective method of deduplicating the training data to remove similar or identical examples, which can reduce the risk of memorization and improve the privacy of trained model. The objective is to provide a practical and scalable solution for reducing privacy risks in language model. Coming to the methodologies. Language models memorize and regenerate sequences seen during training. This makes them vulnerable to attacks that compromise the privacy for their training data. The Carolini attack is currently the strongest and most accessible model inversion attack on LMs. The attack works in two stages, generating a large amount of text from an LM, and second is by scoring the generated sequences using a membership inference scoring method. The first method uses different methods of generating data. They are unconditional versus conditional sampling, total K sampling, and temperature sampling. Results are shown in the figure 2. For the second stage, all scores proposed by Carolini are studied, which are defined as the ratio between a metric estimating the easiness. The measure of easiness include the reference model, zlib compression library, and lowercase perplexity. To detect duplicate sequences, the authors adopt the suffix array based algorithm. Large scale web scraping is the primary method for generating language modeling datasets, which is shown in figure 1. Two commonly used natural language modeling datasets are Open Web Text and C4. Both datasets were generated by scraping text from the internet with basic filtering and deduplication. Coming to the experimental results, the benefits of performing deduplication on training for language models include reducing the amount of training data and speeding up the training process without harming model perplexity. Additionally, deduplication between a model's training and test set is necessary for proper evaluation. However, too much deduplication can harm model perplexity. Moreover, for certain tasks like closed book question answering, memorization of facts from the training data set can be necessary, and thus the deduplication may not be universally beneficial. Coming to the conclusion and future work part. Identify Identifying privacy vulnerabilities in machine learning model is important and should be tracked back to the training algorithms, models, and datasets. Sequence level duplication is a significant factor behind successful privacy attacks on language models. Language models exhibit a superlinear increase in their regeneration rates as the number of duplicates increases, which requires a further investigation. Removing duplicates from training data may overestimate the effectiveness of privacy attacks, and future evaluation should consider duplication as a possible confounding factor. Future attacks should be evaluated based on different data features, providing a better understanding of when attacks succeed and how to defend against them. These are the references. Thank you.